Welcome back. This is going to be the grand finale for completing the square. We're going to do two problems here. Both of them are going to require a little more work, but none of them are going to deviate from the procedure that we have shown you. So we're going to crank through, and we'll have to do a little more work for some of these, but ultimately it'll be the same thing. First question, x squared over 4 minus x is equal to 3. Now the first thing you want to do is you find the x squared term. Is there a coefficient in front of it? Now in this case there is. And I've been telling you the whole time that you want to make sure there's just a 1 here. Here there's a 1/4 in front. We want to clear that. So we need to figure out a way to do that. So the easiest way to do that is just to multiply, well, let's do it like this. Multiply the entire left-hand side by the number 4, and then you multiply the right-hand side by the number 4. Remember, any equation that you have, you can multiply left and right-hand side by whatever you want. And in doing that, the 4 will get distributed to this by multiplication and cancel here. And then it also needs to be multiplied into this term. So you got to be really careful when you multiply both left and right-hand side. You need to wrap parentheses to make sure that the multiplication happens to everything on both sides. So really what you're going to be left with is just x squared, because the 4 will cancel with the 4. And then the 4 times the negative x means you'll have a negative 4x. And on the right-hand side, you'll have 12. Now, doesn't that look a lot nicer? Because ultimately, this equation is exactly equivalent to the previous one that we started with. In other words, it has the same solutions as the equation that we started with. Now, we have a coefficient of 1 here. We check for any constant terms on the left, and there are none. All the constants are on the right. In this case, it's just the number 12, so we're good. Now we continue with our procedure. Negative 4 divided by 2, square the result. What do we get? Negative 2 squared, what do we get? 4. So that's our magic number. We need to add 4 to the left and also 4 to the right, and then that'll give us a perfect square. So let's do it. X squared minus 4x. We add 4 to the left, and we also add 4 to the right. So we suspect, or we better, get a perfect square here. So let's go ahead and try to factor it. X, what times what gives you 4? 2 times 2 looks like it's going to work. We have a negative sign in the middle, so we strongly suspect we'll need negatives everywhere. And on the right-hand side, we're going to get 16. All right, so double check yourself here. Negative 2 times negative 2 gives you the positive 4. Inside terms are negative 2x. This gives you negative 2x. You add them, you get that. So you're good. And then you write it as a square term. Equals 16. That's, again, the end game of all of these problems. You want a square term equal to a number. So we take the square root of the left. That just gives us x minus 2. The square root of the right-hand side is going to be plus or minus, which you have to add yourself, 16. So you have x minus 2 is equal to plus or minus square root of 16, which is 4. So we can take that, and we have two answers. X is going to be, we need to basically move the 2 over by adding it. So we're going to add 2 to both sides. It'll be plus or minus 4 plus 2. We add 2 to the left and 2 to the right. So ultimately we have x is equal to 4 plus 2, which is 6. That's one of the answers. And we have x is equal to negative 4 plus 2, which is negative 2. That's the other answer. So positive 6, negative 2. These are the two answers that we get. And if you take these in and stick it into the original equation or into this slightly modified version of it, it's going to satisfy. Both of them are going to work. So you see, we just had to insert one extra step. Clear whatever you have here. If your equation was 3x squared here instead of 1/4, to get rid of that 3, you would need to divide the entire left-hand side by 3. Divide the first term by 3, divide the second term by 3, and you'd also have to divide the other side by 3. So multiplying and dividing can clear any coefficient in front of the x squared term.